Hi everybody. So last time we were together, I just finished up talking about the bronchial tree and the alveoli, which are the small air sacs of the lungs. And I talked about different kinds of cells that are found in those alveoli. Well, one of those cells is kind of important right now, and those are those type 1 pneumocytes. They're also known as the ACE2 cells. So those ACE2 cells are the cells that are producing that angiotensin converting enzyme. All right. So those cells, they have that ACE2 receptor protein on them, and what's interesting about that for what's going on right now is those are the proteins, those ACE2 proteins that the coronavirus is attaching onto to infect these cells. All right, so now let's move on to the lungs here. So the lungs are the organs of respiration. We have 2 lobes to our lungs, so we have the right lung lobe and the left lung lobe. And the left is a little smaller, and that's because the heart is found right in that area. All right. The lungs are basically made of alveoli and a lot of little tubes in there, so they're soft and they're spongy and they're kind of cone-shaped in appearance. All right. There are subdivisions to these. There's these lobules, and each lobule is served by a bronchiole. All right. And the connective tissue between those lobules can be blackened by smoking. All right. Now let's move on to our next main topic that we're going to look at, and that is the breathing mechanism. Now this is the pictures out of your book, and I'm not a huge fan of these. Let's move on to these pictures here, which are a different book. So what we have to understand is that there's air pressure around us all the time. And that air pressure is known as atmospheric pressure. This is a pressure exerted by air gases surrounding the body. And this is equivalent to 760 millimeters of mercury, or 1 atmosphere. All right? So if an air pressure is above 760 millimeters of mercury, it's said to be positive air pressure. It's below that, it's said to be negative. All right? So what we need to understand about gases, unlike a solid and a liquid, is that gases are going to fill their container. So what happens here is if you reduce the amount of gas molecules, they're still going to fill the container. It's just you're going to have less gas molecules there, and so you're going to have less of a pressure. So what we see with gases is that air pressure and volume are inversely proportional. So if we increase pressure, so if we decrease the volume, we're going to increase the pressure. All right? And so also what we should know is that gases are going to move from a higher pressure to a lower pressure. So if there's an opening, gases will move in that direction. The other pressure that we're concerned with is what is known as intrapulmonary pressure. And this is the air pressure that's within the lungs, or the alveoli. So we look at inspiration and expiration, these breathing mechanisms. So the first one is inspiration, or also known as inhalation. All right? And this is a period when air flows into the lungs. And so in order to get air into the lungs, we're going to do a couple things. One is, here is the diaphragm. So this is a muscle that separates the thoracic cavity from the abdominal pelvic cavity. And another muscle that we're going to use are these muscles found in between our ribs, and those are called external intercostal muscles. All right, so these are what you would eat, if you go to a nice barbecue place and you order some ribs. Well, not human ones, but you know what I'm saying. Anyway, so what happens in here is we're going to contract the diaphragm. So by contracting the diaphragm, that's going to move down. Now what that's going to do is it's going to push all the organs in our abdominal pelvic cavity down as well. All right, we're also going to contract these external intercostal muscles. And what that's going to do is it's going to cause the rib cage to move up and out. And what that is going to do to the volume in our thoracic cavity, it's going to decrease the volume in the thoracic cavity. And so increase the volume in the thoracic cavity. So that's what's going to happen there. We're going to increase the volume in our thoracic cavity, and by doing so, we're going to decrease the air pressure within the thoracic cavity. And so because there's a lower air pressure inside the thoracic cavity than what's found outside, air is going to move into equal pressures. So just like the same thing when you pull on a syringe, air moves in there. That's essentially what we have done, the same thing here. All right? For us to use, taking larger breaths, we're going to use our sternocleidomastoid, this large muscle here, and also our pectoralis minors to help raise the rib cage up a little bit more. All right, so that is inspiration. Now let's take a look at expiration, and this is the period when gases exit the lungs. Expiration is also known as exhalation. All right, so I just want to point out something. Normal expiration is a passive process, meaning it doesn't require energy, because all we're going to do in here is we are going to relax the muscles that we contracted in inspiration. So what happens here is when we relax the diaphragm is all the organs in the abdominal pelvic cavity down here are going to essentially push back, all right? And so that's going to push the diaphragm back up, and we're going to relax those external intercostal muscles, so the rib cage is going to depress. And in those two processes, that's going to reduce the volume in the thoracic cavity, all right? And by reducing the volume here, that's going to increase the air pressure within the thoracic cavity, and so air will then get pushed up and out of our lungs. So normal expiration is just a passive process. We just relax those muscles that we contracted in inspiration, all right? So in a forced expiration, like, if you're blowing up a balloon, or you're running, exercising, we are going to contract some other muscles to help even make our thoracic cavity even smaller. So we're going to contract abdominal wall muscles down here. That's going to force the organs in here up further, pushing up more there. We're also going to contract what are known as the internal intercostal muscles. So these are some of these muscles here, but that's going to cause that rib cage to depress a little bit more. And those are going to help push air out of the lungs even more. Okay.